All right. Um, Today we're going to do some review of the JavaScript and Python programming languages. We're going to talk about why these languages matter, and we're going to talk a bit about the different parts of programming. And just to kind of kick things off, and again, just so it's not my voice we're hearing all the time, could I get a volunteer just to read this whole section right here? What are we trying to accomplish?
I'll read it.
Perfect. Devin, thank you, sir.
All right. What are we trying to accomplish? Modern software engineers are expected to be language agnostic problem solvers who can reason about logic, data, and control flow regardless of syntax. In this lesson, students are introduced to JavaScript and Python side by side to build a strong foundation in programming fundamentals that translate across the entire software stack. Rather than treating these languages as isolated tools, this lesson emphasizes their shared concepts such as variables, data types, conditionals, iteration, and functions, while also highlighting where and why they differ. Students will learn how each language fits into real-world engineering workflows, from front-end development with JavaScript to back-end services, automation, and data processing with Python. By the end of this lesson, students will not only be able to read and write basic programs in both languages, but more importantly, they will understand how to think like a programmer, breaking down problems, choosing appropriate control structures, and writing reusable, maintainable logic.
Devin, thank you very much, sir. So this touches on a couple really key points. Um, this sounds a little counterintuitive, but coding is the least important part of software engineering and programming. At the same time, it's very clearly, but it is the biggest barrier to entry. Right now, maybe in the future with AI, none of us will have to learn to write code and deal with typos and syntax errors, but that is definitely not the case right now. And I don't think it will ever be the case because really, what a software engineer is someone who uses computers and software to solve real problems, right? Like, say, business problems. And someone who can be a bridge between people and technology, right? And this means talking with stakeholders in other teams, departments, understanding users, and really being creative. Um, Especially at the big West Coast tech companies, the value of the software engineer is the business value and the things that they have. Um, the other thing I want to point out here is that technologies, frameworks, and languages have specific details, but concepts are universal. By mastering one specific language deeply, or framework, or technology, such as React.js or Django, you will learn and master many concepts that are everywhere in computing, and it will help you learn and use other things more quickly. By going deep into one thing, you'll learn concepts that are mastered in another. And it won't feel that way now, but you'll see this by the end of the course. Later, we will be learning about Django, Python, object-oriented web framework. We'll talk about it later, but in short, the framework Django has a very similar equivalent in a different language called PHP that has a lot of similarities with Python, and another language, Ruby, that has a lot of similarities with Python. Um, and there's a Laravel in PHP, there's Ruby on Rails and Ruby. In the language C Sharp, there's .NET. And so the concepts really are universal. Um, Learning JavaScript and Python together is hard. And this is what we call context switching. It is hard. Professional devs avoid it because it hurts productivity. There are actually a lot of studies show that it helps learning. It just isn't fun. Like it's really easier to focus on one thing, but there's actually a lot of learning science research that shows that going back and forth can help you master stuff. Um, Learning JS and Python together is a trade-off. A lot of boot camps just focus on one. Um, the pluses are JS is the language of front-end engineering, of building websites and user interfaces and things like that. Python is the language of back-end engineering, which is part of full stack, data science, AI, and machine learning. Python being an object-oriented language, which we'll learn about next week, also sets you up to learn C Sharp, Ruby, PHP, Java. And we've had many grads, though many of those grads did have prior experience before coming in, but they got hired for one of these other languages. And as to this point, as a software engineer, it's not uncommon to get hired for a role where you will have to learn a new language or technology on the job. This is actually really normal. So to a degree, the specific skill sets are important, but not entirely. So these shared concepts are really, really important, right? And let's talk about these shared concepts and how to think like a programmer and what that is, and then we'll dive in, and in just a minute or so we'll be writing some code. So what is programming? Programming is using software to create a universe, right? A little model of a world. That world could be airline reservation tickets. It could be an RPG game. It could be a tic-tac-toe game. But we kind of get to play God and design a universe and decide if I'm making a tic-tac-toe game, how does that universe work? How do I store the board in my program? So every program has a couple. So first of all, programming is about understanding the universe we want to model or the problem we want to solve. You'll hear this called the domain or business domain. You'll hear this called the problem or problem scope. And the biggest part of this is asking questions and playing with ideas. Sometimes the problem is straightforward, and my task is to follow the recipe and bake the cake, right? We know what we have to do, and it's writing code is sort of like, and making an algorithm is sort of like following a recipe. And really writing a program is like creating a recipe. Sometimes I have to figure out what the heck the problem looks like. And this takes us to, the parts of a program. How do I do this? right? If I say build a tic-tac-toe game, how can I think about this? Every program has these elements are uh, rather these are the these are the parts of a program. Data. This is actually the most important. Think about, try to imagine a program without any data. Can you have a tic-tac-toe game if you're not storing where the moves are? Think about if you're printing out a message that says hello world, that string that where you're saying hello, that's data, right? This is information. If you're writing a program for online ticket reservations, the name of the person, the time they got the ticket, all those things is data, right? This is information. If you think about it, it's probably impossible to write. If you wrote a program without information, it would be sort of like a math formula almost. A program has to have logic. You know, we call this code, uh, the algorithm, set, right? What do I do with the data, right? So, right, it could be, for example, you know, airline ticket reservation info, users, flight numbers, etc. Right? What do I do with the data? Store a flight reservation, cancel a reservation, check if a seat is available, right? This is all an example of logic. Finally, a program has input. This is data we send in to our program from the outside world. Not every program is going to have input, but most do, right? If you're making a tic-tac-toe game, the moves on the board, and then a program has almost always has output. Data the program sends out. For example, printing a tic-tac-toe board with all the moves on it to the command line, right? Or just saying printing hello world, right? So just to recap, we have data, which is actually the most important. We have logic, we have input, and we have output. Again, these are concepts. This is universal, right? This is not about JavaScript or Python or anything else. And especially when we get into code wars, leak code, these kind of algorithmic puzzle kind of problems, if you start thinking about your world in terms of data, logic, inputs, and outputs, and ask, what's my data? What's my input? What's my output? Then it will really help you solve these problems. So I know this is a bit of an abstract preamble. We'll do a little more talking and then we'll kind of start writing some code. Could I get a different volunteer, please, to read this part of the intro?
Sure.
Thank you.
Intro. Modern software engineering rarely relies on a single programming language. Instead, engineers choose tools based on the problem they are solving. JavaScript and Python are two of the most widely used languages in the world, and together they cover an enormous portion of today's software landscape. In this lecture, we introduce JavaScript and Python, explain why both are beginner-friendly yet professionally powerful, and establish a shared foundation for understanding how programming languages work at runtime. Rather than treating them as competitors, we will frame them as complementary, did I say that? Yeah. Complementary tools that often coexist within the same system.
Awesome. And thank you, Liz. And let me talk a little bit about JavaScript and Python. There's a lot of text here, so I'm not going to ask someone to read it out or for us to kind of go through the whole thing. Please do take the time to read it. But let me just hit key points. What makes JavaScript the most popular programming language in the world? It runs directly in the browser. What do I mean by that? If in the browser, I go to this inspect sidebar where you have all of these tools for front-end engineers and web developers, which we will learn about later in the course. I go over here to where it says console. I can write and run JavaScript code because every browser has a JavaScript runtime engine. And in fact, I have a couple files here. Let's open up my JavaScript file. When we write JavaScript here outside the browser, this file that I'm writing now is on my computer, right? And I use the Node.js or the Node program, the JavaScript runtime or interpreter to run and execute this code. Oh, and it would help if I passed it the correct file name. Node.js is actually the same JavaScript engine here that's in the browser. Google created the Chrome browser. Their JavaScript engine is called V8. And the guy whose name I can't recall at the moment, who created Node.js, he liked JavaScript so much and decided it was good for certain things that he and the V8 JavaScript engine is open source. He grabbed it, wrote a bunch of C code in another language so it could work server side on our computer outside the browser, and we now have Node.js. Node.js didn't exist till like 2010 or something, and before that, the only place you were running JavaScript was in the browser. And every time you do something interactive in the browser, some of it is with CSS, which we'll talk about later, but something like this, where I search, and let's search for a museum, all of this that's coming up here, this interactivity, and when I click on this, this is all JavaScript running in the browser and kind of controlling what the browser is showing. So that's a huge reason why JavaScript is an important language and why it's the language of the web. It was originally created in the mid-90s to make web pages interactive. It was actually created in 2 weeks at this company Netscape, so the story goes, which was a browser company. Netscape went out of business, but the people involved with Netscape created the Mozilla Foundation, which runs the open source Firefox browser today. JavaScript has grown dramatically beyond its origins. Today, powerful UI frameworks like React make it the language of choice for building most user interfaces, and is why websites are really web apps now and are super interactive. Way back in 1992, really, a website was, we would call it static, right? It was text and images, and just getting something to pop up like this or having a cute little animation was a big deal. These days, we have full-on programs running in the browser, and the browser is really like a delivery system. As I mentioned, it's also used on the server now with Node.js. It's used on the server with Node.js. JS is not really an object-oriented programming language. We'll talk about that later. It's more event-driven. Let me talk now about Python. And actually, let me pause and check in and see if folks have any questions, as I've been doing a lot of talking here. Do folks have questions, or is anything on people's minds? Cool. And how are we doing on a scale of 1 to 10? Awesome. Alex, I saw that link you dropped in the Zoom chat. That looks great. If you could drop it in Corsair questions at some point, I would appreciate that. Different languages have different design philosophies, and that changes how we write code with them. And kind of like a golden rule of programming is use the tool the way it's designed to be used. We write JS code using different patterns than we do for Python code because the languages have different design philosophies and work in different ways. The same way that if I have an electric car, I'm not going to a gas station to fill it up, right? So was Python was created with a philosophy of readability and simplicity as priorities. And in fact, there was this guy, Tim Peters, was like hugely a huge contributor to the Python language, as it says here. I can't remember the name of the guy who created the Python language. He's from the Netherlands, and I would struggle to pronounce his name. There's sort of some sort of nonprofit organization, I think, that sort of owns the Python language, as is common with a lot of this stuff. But the joke is the language creator of Python is the benevolent dictator for life, or BDFL. But this one contributor wrote the Zen of Python. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. So on and so forth. Readability counts. In the face of ambiguity, refuse the temptation to guess. There should be one and only one obvious way to do things, which is a big one. And so you'll see that as you learn this stuff with every language and with every framework, there's sort of different communities and different kind of like standard practices have evolved. And this is a big part of programming and software engineering too, is learning these best practices. So it's not just me off on my own writing code. I'm engaged with my community of peers and practitioners. Python is hot. It's hot right now. It's used everywhere. It was used in scientific computing for a really long time because it had some great math and data processing libraries. And that's why it ended up being used a lot in data science and data analytics. And that's why it ended up being used a lot in machine learning and AI now. But you do also see Python in backend code, or code for full stack for the back end of web apps. So Python is a quite valuable language to be learning right now. It's also extremely beginner friendly. A lot of universities use Python as the language they teach undergrads. MIT famously switched to Python sometime in the early 2000s, which was a big deal because they used to use this other language called Lisp. Python and JavaScript have some similarities. They're both called interpreted languages. That means we don't have to compile them. With some languages, I have to write my code, run a program called a compiler that generates what's called bytecode, and then I run that other thing. This is languages like C or Java. JavaScript and Python are interpreted languages. I can write code and use the interpreter to run them right away. Related to that, they're called dynamically typed. What this means is variables can change type. If I go here to my JavaScript code, I can say x equals 5. So this variable now is a number type. I can change the value of x to a string and print it out. In what are called strongly typed languages, this is not allowed, and this would actually throw an error. And you actually have to often declare the type of a number or the type of a variable when you create it. And this is true in Python as well. And I'm going to open up a split here in VS Code. If we go to editor layout and we do split left, is that what I want? There we go. Perfect. So we'll put that over there. We'll put the JavaScript over there for the moment. Let me get my split back. Let me open up my Python code here, kind of get my world organized. Not right now, but as your programs get bigger, you'll probably want to write splits. Note how, and actually I made a mistake here in JavaScript. We really should be putting a keyword in front of the variable declaration, and I'll talk about that in a minute. In Python, first of all, note how much cleaner this syntax is. And Python is also a dynamic language, right? X can change values. So we're not going to dive too deep into like the different kinds of programming languages or differences between them, but I just want you all to be aware of this, right? So this is a big deal. It makes these languages really flexible to work with. There are some key differences. JavaScript follows a paradigm called event-driven programming and asynchronous behavior. And we'll learn about this later. But what it means is code doesn't always run top to bottom in essence. You can do things like make a HTTP request over the internet and not block your code. So that if I want my JavaScript program to talk to the Google Maps API to get latitude and longitude for the name of a city that I'm giving it, my JavaScript program won't stop while it's waiting for that. Python is what we call synchronous. If my Python code is making an HTTP request over the internet, the entire program will stop and wait until it gets back a response. And you could imagine how if I'm building a user interface like Google Maps, the synchronous code where code stuff doesn't block could be a bit better. Or if I'm writing a real-time chat server that's going to have thousands of users, the asynchronous code where that doesn't block would be better. And in fact, much later in the course, we'll learn that when using Python on the back end, we need to use some libraries to help tackle this problem of synchronous. Because if I have 500,000 users all talking to my Python server all at once, it can only handle one request at a time. So let me just now, we have some examples here. Let me pause and check in real quick. How does this work screen-wise with the curriculum here on the left? Is this useful or is it too distracting while I'm writing code?
Works well.
Okay, awesome. Then I'll leave it up. And also there are some lovely diagrams there. So now I'm going to shift more into code writing. Why don't we take a short 5-minute break actually, and then when we come back, we'll be getting hands-on. I'll be writing more code and reviewing, just showing some language concepts. All right, thank you very much, everyone, and I'll see you all in 5 minutes.
Hey Adam.
Yes. All right. We've done a lot of good conceptual background and talking here. Let's start writing some code. So we're going to cover variables in Python and JavaScript, how to create them. We're going to see setting up some Docker images and Docker files to run Docker containers to run our JavaScript and Python code in. We'll talk about one kind of data called primitive data types. And remember, these concepts cut across programming languages. We'll see more complex data types like arrays or lists or objects and dictionaries. I'll talk a little bit about data you can change or mutate that we call mutable versus immutable. Let me hop over to our code. So variables. We'll learn about functions and classes later, but sort of the fundamental thing in programming is data, and that's a variable, right? A variable is a name that's an empty box for some sort of value. And the way you create a variable is, as you can see here, you give your variable a name here on the left of the side of the equal sign. On the right side, you give it the value that you want. You can sort of combine things. So you can have a whole bunch of stuff on the right side of the equal sign, and hopefully I got that logic right in Python. And how you create or declare a variable is different depending on the language. Different languages also have different naming conventions. For instance, in JavaScript, it uses what's called camel case. And when I declare a variable, I have to use a special keyword in front of it. Often we will use let. There's another one called const I'll talk about a little later. And here we have a username. In JavaScript, you have to put a semicolon at the end of the line, though with modern JavaScript, this is less important. You can do all sorts of things with this variable once I've created it. I can modify it, right? I can even use the variable name to reference itself. I don't know anyone named Alex Smith, but they are now officially great. And this camel case convention means when I'm creating variable names, the first part of it is a lowercase letter, and then I use uppercase letters with no spaces, and it's supposed to be like humps of a camel. So when you're writing JavaScript code, you have to, it's incredibly important to follow this convention. In a professional context, people will immediately call you out if you don't. And the reason is, think about if you have thousands of lines of code, you need consistency in order to not lose your mind. So programmers get very serious about naming and language conventions. In Python, as we've seen, we don't need this let keyword at all. And Python follows what's called a snake case naming convention. And someone thought that by having all of the parts of a variable name have be lowercase letters and this underscore between the different parts, it somehow looked like a snake. I don't need a semicolon at the end. And again, I can do the same sort of reassignment by using that variable name. And let's give Alex a last name here. And let's print out Alex's last name. Note here, by the way, how I forgot to add a space between these two parts. Little things like that happen all the time in programming, and that's why we kind of emphasize such a hands-on focus, because you'll learn all these small details that end up being very important in terms of working with data, and you'll develop your programmer brain, so to speak. We'll see some other conventions around naming variables later. A constant is when you have a variable that you know isn't going to change. So for example, if here in Python, like US country code equals, I think it's just US. I can't remember if it's US or USA. Right, the Great Britain country code is, I think, just UK. And we'll just print the UK one. This is a constant value because in the universe I'm creating, this country code never changes. It's always going to be UK, right? And that's because of what it is in the real world. Though sometimes for other things in your programs, that might be the case. So this is how when other programmers read my code, they know that this variable is never supposed to change, and they respect that rule. There's nothing stopping me from changing it. But it's like a stop sign. You're supposed to follow the rules and not do that, right? So programming is all about conventions. And in JavaScript, it's the same convention. There's a const keyword that actually makes it so you can't change a variable value, but you still would write it like this with the uppercase. Oh, excuse me. And let's go ahead and run that. And I need to give it the JavaScript file. So let's talk a little bit about using Docker to run our Node.js and JavaScript code. Now, the cool thing here is in this from statement in the Docker file, there's official Docker images on Docker Hub. that have some version of Linux, but they have Python installed, and this one has Node.js installed, and it's super slimmed down. Now I'm going to organize my code a bit because you normally want to name a Docker file just Docker file. So I'm going to make a directory for JavaScript and one for Python. And in fact, let's move my JavaScript file into the JavaScript directory, and let's move my Python file into the Python directory. And we'll close these out and come back to them in just a second. And let's go ahead and tackle the JavaScript one first. And you know what? I want to name this to example.js, like it shows in the example here. So I'm going to rename this file. And I can actually use that same command line move command. If I just give the file that I want to rename, and I say move it from here to here, we're not moving it to a different part of the file system, but we're giving it a new name. And let's create a Docker file. And let's set up our Docker file. Let me make sure my code is still there in JavaScript. Let me run it to make sure I didn't do anything silly. And let's set up our JavaScript Docker file now. And so I'm going to use this base image for Node.js and note these wonderful autocomplete helpers that I get from VS Code. I'm setting the working directory. So inside the Docker image, inside the Linux in there, it's going to do work in the directory app. And from outside the Docker image from my file system, I'm going to copy example.js to that work dir. And now we're going to run the Node.js command and run our code. And give me just one moment here. There we go. Apologies. So now I've got my Docker file. I want to build my Docker image. And let's call this just JS example. And I have an error. Cannot connect to Docker daemon. Daemon is a fancy word for a program or process sort of running in the background, right? Like, so on your operating system, there's all sorts of programs running in the background that we don't see. And it's looking for that Docker command line program, and it's not there because I did not start Docker Desktop, which is what I need to do on a Mac. So we'll give Docker Desktop a moment to spin up. Now that Docker program should be running in the background. Beautiful. We see my image building. It looks like it built successfully, so let's go ahead and run it. And I think I need a little help here. Did I get this command right? The --rm to remove the container once I'm done. Cool, I see some thumbs up. Let's go ahead and run it. And we see our code printed out. Right? And so this is useful because, for example, we might start to have a lot more dependencies. There are ways to set it up so maybe you're always running code in a Docker container. I wanted to demonstrate this. In the interests of time, though, for the lesson, I am going to continue to run code outside the Docker containers and images just to walk through the various language features. But what we would do is, just to show the example for Python, we would go into the Python directory. Let's also go ahead, right, and move this to example.py. And let's create a Docker file here for Python. I'm going to close out my JavaScript Docker file so I don't get confused. Open up the Python one. And write the Python Docker file as well, right, which is going to be from Python 3.11 slim. And it's the same approach. I have a couple typos I need to fix in just a moment. Let's go ahead and fix that typo. Let me make sure I spelled everything right. I think that looks good. So now if I do Docker build, like I said, I don't remember anything. I always am looking stuff up. So build dash T and let's do Python example dot. And it looks like I have an error in my code, failed to build, Pute. I made a typo in renaming it, so let's fix that. Note, by the way, in this error message, it says example py not found. And then here in the error message, it's pointing to line 3 as where it's causing the problem. So when you get error messages, it's super arcane. I know it's really important just to slow it down and read through because often there actually are useful hints, right? Because here we can see this actually points exactly to what my issue is, which is not always true, but often is. And now if we try to build again, build successfully, we'll give it a minute to finish up. And let's go ahead and I'm going to use the Control R to search through my command line history to search for run, because like I said, I don't remember all these commands unless I'm doing it all day, every day. And then our Python code runs. So what I do want to point out here is we now have a project officially. I have a directory for my JavaScript stuff and my Python stuff. And I have a Docker file for each part of my project organized. And the more and more that we write code, the more and more this project structure becomes important. And then it starts to matter which directory I'm in when I'm running certain commands, right? This is where we are right now is our project root directory or base directory. This is sort of the home base of the project. But I can't run those Docker build commands the way they are in here because I'm not in the same directory as my Docker file. So project structure will become more and more important over time. Let me go ahead now and let's talk about primitive data types. And I am going to set up a split here. And let's again put Python on the right, and we'll put JavaScript here on the left. So a comment in JavaScript, you can do it with 2 lines like that. In Python, you would do a 1-line comment with a pound symbol. So every programming language has a couple different data types, and one is a string, right? And this is text. It's a bunch of characters in JavaScript. We've seen this. It looks like this, hello world. You can do it in single quotes. The problem with single quotes is if I want to use like a single quote in there in my message, that code will not run as the red squigglies indicate. You can add what's called an escape character to tell the language that this is not the end of the string. This is actually a part of the string, but often it's just easier to use double quotes. Right, and in Python, and there we go. I forgot my variable name, the most important part. And in Python, it's the same story, right? If I did hello, it's sunny. We see the red squiggly. This is a syntax error if I ran my code. In fact, let's go ahead and run this Python code. We see this error. It says unterminated string literal, right? It's gotten confused by this. I could add the escape character, but it's usually just easier to use double quotes. So it's good to know about the escape character, and let me drop that example in here just so we can see it. I think those are the main things about strings. There's a lot of different ways to manipulate and work with strings. The one thing I want to point out is something called a string literal. Let's say I want to say like, hi, Alex, and then I want to put my message variable here. Well, I can do it like this, but I can also do it like this. If I use a backtick, and then I use this special format that's called a template literal or string literal, I can put a variable inside here. And here we see that code run. So both of these work, but as your programs get more complex, this approach becomes very flexible. So I recommend starting to get comfortable with it now. And in Python, we can do the same thing. If I said, in Python, they call it an F string, so it looks a little different. I would say, hi, Alex. And now I can just, in curly brackets, put the message. And I think that should do it. I think I have my syntax right there. Yep, and the syntax gods are with me. So these are both really useful tools in the toolbox. Let's go ahead and let's talk about numbers and integers in programming languages. So first off, if I want to make a multiple line comment in JavaScript, I do it with this old school format coming from this programming language called C, where there's a slash and a star. Often you'll see like people end up, or the VS Code might insert like extra stars. People kind of have feelings. You'll see people do stuff like this. There's all sorts of different ways to do it. But the main thing is you got to have the opening slash and star and the closing one. In Python, the way to do a multi-line comment is what they call a doc string, which is those 3 double quotes. And actually, the nice thing about a doc string is you can use it to build a variable with like multiple lines a bit more easily than you could in other ways. And it would help if I printed that out. There are other ways to do that with what's a slash n, what's called a new line character. That's good to take a look at, but that's a really useful tool. So with numbers and integers, computers store stuff in binary. This means that there's 2 important types of numbers. Integers, right? Integers are sort of whole numbers, -5, -4, 0, 3, 20, 250, and what are decimals, or what the computer calls floating point number types, -0.25, 0.4, 5.3. In JavaScript, though, JS just has a number type for both. Though there are a couple exceptions, but in general, it just has one kind of number type. And we don't even really have to think about this. I can just create a variable and assign it a variable. And I don't have to worry about it too much. And JavaScript handles this under the hood. And this is part of what higher level languages like Python and JavaScript, interpreted languages, as opposed to languages like, say, C, do for us for free. And in this console.log function, I can not only print a number, but I can like perform an operation. Right? I can put these 2 things together. And if I go ahead and run my JavaScript code, we'll see that it gets printed out. Right. And we have -4.5 down here. And with Python, it's the same, where there are ways to explicitly create integers, or if you're dealing with a really big number or special cases, but 99% of the time, we just say like, we just create the variable. Can have many decimal places that I want. Maybe, I decide I want to actually add them together. And that's what I want to print out. Let's see, we're on the hour. Why don't we take a short break and then we'll continue with Boolean data types, which are really important, and a couple other data types. Is everyone okay with a 5-minute break? Okay, thank you. I realize my preamble ran a bit long, so I want to make sure we cover most of the ground that we have to. Thank you very much, folks, and I'll see you all in 5. We'll pick this back up with talking about Booleans with true and false. All right, so we were talking about different kinds of number types. Let's talk now about Booleans. Which is true and false. We're going to come back to kind of working more with Booleans with conditional statements in part 2 of the lecture. But briefly, in JavaScript, right, we would write a Boolean like this. In Python, we would write it in snake case like this. Whoop. And in Python, I'll just use the Python example. Let's go ahead and run and view that code. Now, I think with Booleans, I do want to mention one thing. Well, we'll come to conditionals and other things with Booleans later, but we'll stick with variables for now. This next data type is pretty important. It's what's called, right, a null value in JavaScript, or in Python, it's what's called none. And it represents nothing but on purpose. This is not 0, right? 0 is an actual value. This is not an empty string. That's an actual value. A good example of why null or none matters. A user submits their info but has no middle name, right? So we might have, first name equals Alex, last name equals Smith, middle name equals none, right? It's not an empty string. It's not a string with a space. It's not that we would do this, but 0. This null type is there explicitly to say this variable, it has a name, right? Because the way we've designed our program with every single user, it'll have these properties, but there is no value for this particular user for that middle name. And in JavaScript, the keyword is null. So middle name here would just be null. And if we print that out, and let's see here, I have to type exit. I somehow got myself into the Python REPL. And actually, that's a good thing for me to show, which I'll show in just a minute. And there we have null. And if we did the same thing with Python, we would see none printed out. Oops, excuse me. And it will help if I actually add print statements. So Python does have a floating number type. We don't have to explicitly declare it. The Python interpreter will look at when we declare this value, see that it's not an integer, that it has these after it, and print this out. And let's actually talk about this real quick, because there is one thing I want to show with this. So I can print this price out in Python, right? And not surprisingly, we see the price printed out. But maybe instead of printing out the value of the variable, I want to see the type of the variable. And Python has a special function keyword named type. And if I put this here and I run this, and I screwed up the syntax here, I apologize. So actually, let me do a quick Google search to get this right. And I forgot to
Parentheses.
type. Yeah, exactly. Thank you. Type is a function. And we'll talk more about why it says class here, but here we see this is float. Under the hood, every single variable or function or anything in Python is a special kind of data called an object that we'll learn more about next week. And so in terms of designing universes, the way the Python language is designed, everything is an object. Oh, excuse me. In JavaScript, that is not true. And so if I did print, let's make just an integer price, and we'll just make it 10. And if I print the type of integer price, we'll see that it's an integer, right? So Python does a little work here for us. By the way, you can also do things like print type. If I just want to say hello world, we'll see that that's a string. I could do, what is the type? And since type is a function, which we'll talk about in a bit, it returns a value. And let's just throw in none. And let's print what is type. And we see that none is indeed a type. In JavaScript, getting types is a little weirder and trickier. Let's see it in action here just with the middle name, for example. And this is where I got confused. We use a type of operator. It really should be a function call with parentheses, but for some reason, when JavaScript was designed, that is not how the language was designed. So now if I run this, well, null, many things are also objects in JavaScript, though it's a little different for reasons I don't want to get into at the moment, but let's try this with a string and see how we do. And that's more of what I was expecting. And so here we can in fact see that in JavaScript, not everything is an object, right? And so again, think about designing a universe. Like the people who created these programming languages got to decide how these worked. And we can see here that in JavaScript, both of these are the number type. There's no float, right? And when I was talking about primitive types before, primitive types usually mean things that are not objects. We'll learn about dictionaries and lists in just a minute. But in JavaScript, we really see here, like these are primitive types. None is sort of a middle ground. These are too, but in other languages, it's a stricter difference where like a string is a string. A string isn't made up of anything else, though in fact, we'll see a string sort of is, though a character isn't. A Boolean is a great example. Like a Boolean is a Boolean. There's no other kind of data type that we use to build our Booleans. Let's talk. Oh, I do want to talk about one thing unique to JavaScript, which is something called undefined. And this is part of the joy and pains of JavaScript. I can create a variable that has no value. If I print out that variable, it prints out undefined. This variable exists. This doesn't throw an error, right? If I just did this, we would see an error. the error, if I scroll up, often the useful part of an error message is either at the top or the bottom. A reference error means the JavaScript was trying to find where this variable was created, what this symbol Y refers to, what's its reference, but it couldn't find it. Y is not defined. We can define it and not give it a value, and it prints out as undefined. And then, in fact, if we do type of, we see that JavaScript has an undefined type. If in Python I do this, you can't even do this because I think this is going to throw a syntax error. Right, and we see name Z is not defined. We see here, if we look up, it's coming from line 76. The line number in error statements, there's sometimes a trace back where you see all of these lines and line numbers with like going deep in other libraries. But you want to look for a line number for your code, and that's the useful bit. And Python doesn't even let me create a variable with an undefined value. Right? No undefined in Python. So again, we get to create universes and decide how these universes work. Let's talk, and let me just pause here and see if folks have questions or stuff that we're curious about. Okay, cool. How are we doing? Cool. Let me create some new files here. Let's make a JS file for complex data types, and we'll name it JS. Let's make a Python file for complex data types, and we'll name it PY. Just as these files are getting a little cluttered up. So we'll put that one there, and we'll put that one there. And let's start talking about complex data types. Complex data types can hold other types of data. That's why we call them complex. Right? And let me scroll down a bit here as I've kind of fallen a bit behind. And we have here a list, and we're going to start with the list. And we're going to start with, in Python, a Python list. In JavaScript, it's called an array. Though it's not really a true array in the computer science sense, which is something we'll talk about later. And lists, as the name infers, stores lists of stuff. The key thing about a list is items are stored in order. A list guarantees the order of the things in it. And a simple example of this is if we have some colors. So lists are stored, items are stored in order. When we talk about items in a list, we use what's called the index or position of each item because computers are binary. Indexing starts at 0. So items in a list are indexed. And so let's look at, in fact, the type of our colors list just real quick. We see that it's a of type list. And I can print the whole thing. Or I can use what's called an accessor with square brackets to print just one of the things in the list. Like say the first item in the list. Now, Python has a lot of really cool methods for working with lists. If I want to say get like let's say maybe I have more items in the list. Red, blue, green, yellow. Right? So I have 4 items in the list. Maybe I want to get these 2. I can use what's called a slice. And let me make sure I get this syntax right. I use my bracket notation, but now I'm giving the index. So index 1 should give us blue. And I think we go through, but not up to index 3. And let me comment these out and let's run this and see how we do. So this is tricky, right? Because the slice start index is inclusive. Note how index 1 is included in what's returned. But the slice end index is exclusive. Note how index 3 is not, we don't include it, we stop there. And I can do a lot of other things with slice. It's very powerful. But just as a short example to kind of show how this works, let's maybe do some colors. And let's do the same slice. And now if I print out some colors and I print out colors, what we're going to see is that the original list is unchanged. So slice makes a copy, right? Our original list is not modified, and that's a key point. Python is amazing. There's a whole lot more you can do with slice, but I'm not going to get into it too much, though we do have some really nice examples floating around and you can find them online. In JavaScript, it has slicing, but it's a little less friendly. If I'm making an array in JavaScript, which is what JavaScript calls a list, it would look like this. And again, I could do the same thing. Let's say I want to print out the very first thing in my list. I would do it like that, and this should give me red. What you all will find is that there's a lot of language features. We will cover some, but not all of them. I really encourage you all to, as you're writing code, try and take time to like Google how to do things in different ways, because often that's how you can discover some of these language features, and it goes pretty deep. And really starting to master these languages is the goal. So if you need to slow down a bit, but it's to help you master a language when you're working on an assignment, that's a win. Because if you build up that base of your pyramid over time, you get a really strong foundation. I just want to pause and check in and see if folks have any questions. Cool. Let's talk about objects and dictionaries, and then we'll almost be at a good stopping point here. So lists store stuff in order. Dictionaries don't guarantee order. Like the name implies, we use the dictionary to look something up by name, which really means look it up by its key. And in JavaScript, we do this with an object. And objects are sort of like Python dictionaries, but are more flexible and are more embedded in JavaScript's DNA, which we'll learn about later as we get deeper into both of these things. Let's start with the JavaScript object because I think it's a bit simpler and I think we've seen a lot of these before. So I, again, create a variable, but this time I use curly brackets. I will give our user a name and an age. Now, as I start to add more properties to this object, it's really normal in JavaScript to write the code this way. And JavaScript doesn't care.
Yes, Dominique. My name is Devin Caballero Zarate. How you doing?
Oh, Devin, I think you're jumping between
Doing all
things.
right.
All right, there we go. It's really common to write objects this way, right? So in fact, maybe we have middle name. No, I can print this out and we can see Alex. Right, and here we see there is no middle name value. We see his age. if I want to get what's called a property, I do user dot. And this is what we call dot notation. And we'll see this with all sorts of things. Note, by the way, this is what we're doing over here with console.log. By the way, if I use console.log to print out the type of this console object, this is a built-in object that's part of the JavaScript language's standard library or the language itself. Excuse me. We see that this itself is an object and log is a property. This property happens to be a function, and we'll talk about functions a bit in part 2. So objects are really important. They're like your bread and butter. You can also combine these things. Right? You can, in fact, combine these things as much as you want. And now, if I look at my user, we see there's all these properties. And now it starts to get a little more interesting, right? Console.log user.favorite foods. But maybe for whatever reason, I just want to see the second favorite food that they have. Or maybe I want to see their zip code. Excuse me. And this is where, one moment, folks. Oh, excuse me, I've been doing a lot of talking. This is where the complex data structures come from. Can I just get a quick show of hands if folks have like seen code like this before, or written code like this before? Yes, no, maybe. Okay, I see some hands up, some hands down. For those of you seeing this for the first time, I know it can be a bit much. It's often the syntax to kind of go deep into the nested structure that gets tricky. Especially in JavaScript, this is really the norm. And we'll just get better and better at this. But remember when I said we get to design universes and data is the most important thing in a program? How you choose to organize your data is the most important thing. If you organize your data well, your logic becomes easy, right? Like, I don't want my address to look like this. I could do that, but now it's awkward and confusing to the programmer to understand which property of this in which items here are which. Naming these makes more sense for this use case, but for favorite foods, this makes more sense, right? Because it's just a list. So this is where you got to kind of think about your universe and your data. In Python, we can't create a dictionary quite so easily, though it's close. So when I'm creating dictionary keys, I have to put quotes around them. So it has to look like this. And let's see, Alex is going to have an age. And again, he'll have favorite foods. And this will be a list of sushi and pizza. And I'll just very briefly do the address, right, with a zip code. And I forgot my single quotes around pizza, which is why we're seeing those red squigglies, right? And again, I can print my user in Python. And we see all this printed out. Accessing properties is a little different. I can do bracket notation. And it looks, I believe, like this, if I have this right. Yep. But there's a problem with this. And in fact, one of the challenges is keeping the language syntaxes right. Right, and we talk about keys and values. Right, key, value, key, value, key, value. You'll also hear the term properties when we're talking about objects and dictionaries. So you'll hear both of those terms, but we should see an error now with my Python code. Well, actually, I apologize. It looks like this actually doesn't error out. We saw nothing. I think it's giving me undefined. The other way to do this though is we can use Python dictionaries has a get property. So I can get a property on a dictionary this way, and I forgot to close my parentheses there. And the nice thing about the get property is we can give it a default value. So I can pass two arguments here, and if I want, say, no last name. Right, and so get lets us set a default if the key doesn't exist, which can be quite useful. So that's really kind of digging a bit deeper into dictionaries and objects and object properties. There's a whole lot more you can do, but that's sort of a good high level summary. I apologize, I did not kind of scroll down here in our curriculum, but you can see I've added a bit onto the examples that we have, but we're mostly following along. And the last bit we're going to cover, and then we're going to take a break, is mutable versus immutable data structures. So some kinds of data can be changed after you create them. Immutable data cannot. And this doesn't come up a lot right now, but it does later, and it is important. In JavaScript, there are actually ways to declare certain kinds of data immutable. If I use the const keyword, JavaScript won't let me do this. Right, and we see an error, and we see this assignment to constant variable. Sometimes you want to do this because it turns out that changing data gets really tricky really fast. So this can actually help you make your programs easier. The general advice is to always make variables const in JavaScript and only change them to let when you need to. If you're more comfortable with JavaScript, I think that's a great approach. If you're just starting out in your learning journey with JavaScript, make things let just to keep it simpler to begin with. Const is a little weird because and we're not going to get too deep into this now, but I can create this variable and I can the append method is how you add something to a list or an array. And let's run the correct file here. Oh, and I still, my apologies. Let's comment that line out. And I apologize. I'm getting my Python and my JavaScript confused here. It is actually pushed that we add something to an array. So this is a little weird, right? I created an array. I modified it. We're not going to get too much into it now, but from JavaScript's perspective, this variable, this container, to go all the way back up to our diagram about variables. Give me a moment here, folks. Here we go. The container is still the same kind of container. from JavaScript's perspective, the container is still the same thing. It's an array. What's inside the array is not what JavaScript is worrying about. And this has to do with how data is stored in memory, which we're not going to get into too much right now, but we will talk about later. If, for example, I tried to do this, we will now see that same const error as before. Right? Assignment to constant variable. Python has some data types that we're not going to look at too much right now for dealing with immutability. The main one is sets, which is good to know about. You can store multiple items, and they're built in. They have some cool properties. They're unordered, they're unique. The things inside it, you can't really modify. So Python has some useful tools as well. Sets are good to know about, though the lists and dictionaries are really the bread and butter. Let's wrap up here. Let's take a break. Why don't we take 10? And then when we come back, we will start talking about functions and loops and things like that.
I got a quick question.
Yes.
Um, you may have addressed this the other day, but I missed it or I didn't remember. But how do I set up time with a TA or somebody for to like ask questions and stuff?
Oh yeah, that's a good question. Thank you for mentioning that. Just hit up either me or one of the TAs on Slack if you want
Okay.
to set up a one-on-one. Just shoot a direct message, and then
Okay,
we'll put
thank you.
something on the calendar. Definitely.
All
Yeah,
right.
and that goes for everyone else too. If you want to set up a one-on-one for any reason, hit up me or Tiffany or Elia. If we if we can't do it right away, but we can do it later, we'll let you know, but we'll find a time. All right, folks, thank you very much. Have a good break, and I'll see you all in 10 minutes.